Hi everyone, I'm Eda. Today we'll talk about acrylonitrile butadiene styrene production plant. ABS is a common polymer made by polymerizing styrene and acrylonitrile in the presence of polybutadiene. ABS production has been growing over the years and is projected to reach approximately 12.5 metric tons in 2023. Asian market is a really important point to ABS production. The highest demand in Asian countries belongs to out of South Korea. Korea and Taipei are leading the import and export of ABS in 2019. Europe is not as important as Asia in ABS production. Italy, Spain, and the Netherlands are seen in ABS production in the Europe region. China can be called the ABS importer in the world. Considering the export values, it is seen that they are quite low. It generally has moreover 2.5 million tons of ABS imports. Turkey plays a role as an ABS importer. Export quantities are not sufficient as import quantities. Looking at this graph, we see that we can export our remaining product to the Iranian market as the first option and dominate the market. Second option is Romania with fallen export values. Returning the Romanian market to its former activity will be our second goal. In the process concept diagram, we see that we obtain ABS from acrylonitrile, styrene, and butadiene with a suitable polymerization technique. According to the annual tonnage-based capacities of these companies, we have determined the capacity of our factory as 710,000 tons per year. Calculating our raw materials and product on the basis of reaction, the profit margin we get is 1,389. While choosing the location where we will establish the factory, we considered various parameters, and then we choose Denizli, which reached the highest score as the location of our factory. Mass suspension, emulsion, and continuous bulk polymerizations are the options we can use. By scoring, we decided that the most appropriate technique is mass suspension polymerization. By providing raw material input to the process we have chosen at the flow rates you see in the figure, we obtain 20.5 kilograms of ABS pellets per second. In the design of this process, we use ChemCAD to show the diagram, and by using the necessary process control equipment, we ensured the safe and controlled operation of the process.
Hi, I'm Burak. Sandwich polymerization allows for easy removal of reaction heat and operational flexibility for polymer with controlled composition and particle morphology. Then two sandwich reactors are used. Each of these reactors requires a cooling jacket due to the exothermic reaction and agitation mechanism. Operation consists of three sections. Filling period in pre-polymerizer reactor used as sandwich reactor. The conversion is too low for the cool down on this section. This is value that can be neglected. As a result, the conversion value will be used to start the operational period. These two equations should be solved simultaneously by using MATLAB to find the change of temperature and conversion with respect to time for the operation period of the reactor. After 8 hours, the conversion has reached approximately 30%. The pre-polymerizer reactor is then discharged. The design steps and results obtained are available in this slide depending on the estimated reactor volume. The conversion at reactor is 91% and the reaction time is 6 hours. Furthermore, there is a stirrer with jacket that supplies the suspending agent and the water to the second reactor. Its volume is determined to be 70 cubic meters. The first exchanger is used to heat the raw material solution before it's fed into the pre-polymerizer reactor. The length of the heat exchanger has been calculated after the design stages shown on this slide. The design parameters of the heat exchanger in the entire system are shown in this table. The pump power will be determined using the Bernoulli equation. Expansion and construction losses are not taken into account. The inner diameter of the pipe was chosen as 90 mm from the dimensions of standard pipe. The diameter graph was compared to the power graph. Various lengths of the outer diameter ranges were found in this summary table, and then many power values were measured. Polybutadiene from the crusher is homogeneously mixed with its solvents as the acetone in the first mixer. The polybutadiene has softened sufficiently to be mixed with other raw materials. In this chart, you can see many mixers. This diversity has resulted in the required power values. The acetone used to soften the polybutadiene was eliminated in the first dryer. Second rotary dryer is used to remove the 10% humidity from the ABS product.
I'm Miguel Almas. In our plant design, we use 6 vessels. 5 of them are storage vessels and 1 of them is sieve centrifuge. As you can see in the table, for storage vessels, stainless steel selected due to our raw material storage condition. Proper assumption and calculations done, and vessel volume and properties calculated due to mass flow rate and storage times. In sieve centrifuge design, with completing proper calculation, equipment with 1000 RPM selected, and centrifuge power calculated as about 12 kilowatts. At the end, we perform a 3D simulation to provide better understanding to our two-story facility design. In our process, we arrange 23 equipment with proper calculation and estimation. We operate 2 reactors, 4 heat exchanger, 3 mixers, 2 dryers, 6 pumps, and 6 vessels. For cost analysis, first, cost of all 23 equipment calculated as about $12 million. Most expensive equipment is reactor as expected. Then, cost of raw materials calculated due to mass flow rate of raw materials, and according to prices, styrene is the most spent raw material in year basis. And total cost of raw material about $1.5 billion for a year. We obtained the number of necessary operating labor as 24%, and with the average gathered salary, labor cost calculated as almost 1 million Turkish liras for a year. Utility costs calculated due to water and electricity consumption on year basis, and total utility costs gathered as almost 180 million. Of course, we need investment to bring our project to real life, and we gathered the capital investment for approximately 15 million. With considering all these costs and gathered investment values, our total manufacturing cost obtained as about 1.8 billion. At the end of the day, we designed a factory with a capacity of 710 tons and predicted that we would generate an annual income of approximately 2 billion with the anticipated ABS sales price. And with this income, we calculated that our annual profit will be about 260 million. With considering all of cost and profit calculation, our facilities payback time calculated as 6 years and 9 months.
Hello, I am Pınar. I'm going to continue with our environmental impact and safety assessment. We analyzed our ABS production system in 3 different manners. First of all, environmental analysis was made with a checklist method. Possible risks were classified and they were checked in case it is provided. Electrical, equipment, general design and maintenance risk had tried to be prevented by taking into considerations. However, we haven't any backup control system. Backup control system can be set up to improve our operation. On the other hand, possible risks which can be caused by storage, stuff or disposal were analyzed. Precautions were indicated in terms of hazardous situations. Secondly, risk assessment was made with a fine-tuning method. The risks were scored according to their possibility of happening, severity and frequency. If the risk score would be higher than 400, it shows a very higher risk. Therefore, the most important parameters were determined as temperature and pressure. Finally, Hacettepe analysis was made for first and second reactors. Possible causes and possible consequences were indicated. Precautions were suggested in our environmental report. Our company has 710,000 tons per year capacity with 24 employees. We aim to change the export of ABS in Turkey. We want to increase it after our production approximately 7 years later. We want to create an eco-friendly and sustainable future. We examine waste management and environmental analysis meticulously. I hope you will like it. Thank you for your attention.